Challenge video, mixture problems. Mixture problems are a specific type of systems of equations word problems that can be a bit tricky. Imagine that you have a bucket of red paint and a bucket of blue paint. If we put an equal amount of both of those paints into the bucket below, we'd get a purple paint that was halfway between the red and the blue. If we wanted to make paint that was this color, we can see that since it's more similar to red, we would need more of the red paint. That's the idea of mixture problems, that if we know the total amount of pink paint we want, then the amount of red plus the amount of blue must add to that amount, and then we use the percents to figure out the exact quantities that we want. Example, Colleen has a 20% saline or salt solution and a 15% saline solution. How much of each should she mix together to end up with 5 liters of an 18% saline solution? So first of all, if we have a bucket that has a 20% solution and a 15% solution, and we want something that's 18%, we know that we're going to need slightly more of the stronger solution than the weaker solution. Because if we put equal amounts in, we'd end up with something halfway in the middle. Halfway between 20 and 15 is 17.5. So let's think about what we have here. Let's imagine that I have an unlimited supply of my 20% solution, and I have an unlimited supply of my 15% solution. My goal is to get an 18% solution, and I know that I want 5 liters of it. So there's going to be 5 liters in that bucket, and the amount of each of the other two are going to add up to 5. So it might be 1 and 4, or 2 and 3 in terms of liters, or it could be a decimal. When I add these together, I know that 20% of however many liters of my first solution I have, plus 15% of however many liters of my second solution I have, I need that to equal 18% of the 5 liters in my bucket, because that's the concentration of salt that I want. So now I've created a system, and X, as I've marked it on the bucket, is then the number of liters of 20% saline solution. And so therefore Y must be the liters of the 15% saline solution. Now I can write my system in the box and I can solve it. One recommendation that I have for you when you're dealing with decimals, although you can choose to work with them if you want, you could also multiply this equation by 100, and that would get rid of all of the decimals. So I'll do that in my work. As you can see over on the right, I decided to multiply my top equation by negative 15 so that I could eliminate my variable y, and when I solved, I got x equals 3. That means that y, since both of our buckets must add up to 5 liters, must be 2. So I want 3 liters of my 20% saline solution and 2 liters of my 15% saline solution. That makes sense because at the start we knew that we would want slightly more of the stronger solution in order to make an 18% solution. So we should check that we do in fact have 5 liters, which we do, and that if we take 3 liters of a 20% solution plus 2 liters of a 15% solution, then we will end up with 18% of 5 liters. And so we can check that right here and see that it was. Which it does. Don't forget to answer the question that was asked. Try pausing the video and setting up the next system. Are you ready for the answer? Here's the setup. Since we know that we have an 8% solution and a 5% solution, I set up my variables as x is grams of the 8% solution, y is grams of the 5% solution. In total, we want 300 grams, so the amount of each type of solution must add to 300. And then 8%, don't forget that 8% is 0.08 of x plus 5% of y has to equal 6% of our total number of grams, 300. Good luck.